All right, guys, Mr. Antonucci here, and this is everything you're going to need to know cold for AP Calc Unit 2. This is the first unit where we start talking about differentiation. Before we jump in, I want to talk about a couple key ideas and important points. First, you're going to need to know the definition of the derivative. You're going to know the distinction between differentiability and continuity. You got to know the basic derivative rules, including the rules for trig, exponential, log, product, and quotient rules. Now, for the AB exam, this is going to take up about 10 to 12% of it. And again, for the BC exam, since that exam includes more content, Unit 2 is only going to take up 4 to 7%. First thing we got to know is the definition of the derivative. This comes directly from average rate of change, which is basically just change in y over change in x. It's the slope of the secant line. It's slope from algebra. But the definition of the derivative is the limit as h approaches 0 of that difference quotient. The notation for that we'll use f prime, or dy dx will also use y prime. It is very, very important that you have this definition memorized. There is also an alternative definition, which is often used for finding the derivative of a function at a point. You can see the change in y over change in x in this one. Let's talk about differentiability and continuity. If a function is differentiable at a point, then it's also going to be continuous at that point. Sometimes students get this backwards and they think if a function is continuous, it means the function is automatically differentiable. So remember, differentiability implies continuity, not the other way around. When a derivative does not exist, the graph could look like a corner or a cusp, a vertical tangent, or a discontinuity. So here in the green graph, we have a discontinuity. Down from that, the purple one, you have a vertical tangent. And then the last two graphs are illustrating a corner or a cusp. Let's jump into the basic derivative rules. You got to know the power rule, derivative of x to the n equals n times x to the n minus 1. The constant rule, the derivative of a constant is 0. Got to know the sum and difference rule that says the derivative of two functions being added or subtracted is the sum or difference of their derivatives. You got to know the constant multiple rule. This just says if you have a constant times a function, you do the constant times the derivative of the function. Product rule, quotient rule. Continuing on with those derivative rules, you got to know the 6 basic trig functions and their derivatives. So derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. Derivative of cotangent, negative cosecant squared. Derivative of secant, secant x, tangent x, and derivative of cosecant is negative cosecant cotangent. A quick rule of thumb is that if you're taking the derivative of a trig function that starts with a co, the answer also starts with a negative. So look at that, derivative of cosine, cotangent, cosecant, all of the answers start with a negative. Also, you have to know the derivative of the exponential function. Derivative of e to the x is itself, and the logarithmic function, its derivative is just 1 over x. Just a couple quick tips before we wrap it up here. Make sure if you're asked to estimate the derivative from a table of values, you need to show the difference quotient as a setup. So if the question asks us to find f prime of 2, but 2 wasn't in the table, but 3 and 1 were, you would have to have f prime of 2 is approximately f of 3 minus f of 1 all over 3 minus 1. Make sure you're using correct derivative notation, f prime, dy dx, y prime. This is really important because in calculus we have different levels of a function, so to speak. So you have the original function, the first derivative, second derivative. It's important to have correct notation so that we know what you're talking about. So on free response question, if the question specifically requires that the function be continuous, and it didn't state it, but it did say the function was differentiable, then you need to explicitly state that differentiability implies continuity, or since the function is differentiable, we know it's continuous. All the derivative formulas you need to memorize. They show up everywhere, not only in Unit 2, but for the rest of the entire course. All right, guys, that's everything you need to know cold for AP Calc Unit 2. Hope that was helpful to you. Take care.